Hello, my name is Tim Braun. It's May 28th, 2026. We're going to go through the cardiovascular system. So we're going to start just outside of the heart. Once the heart is pumping blood to the rest of the body, and the blood starts coming out of the heart in the aorta. The aorta is the largest artery vessel in the body, and the aorta is going to kind of pave the way for many arteries to start to branch off. And the blood in this system, the aorta, the arteries, the arterioles, is oxygen-rich blood. It has already been in the lungs and it is now ready to enable the body for aerobic metabolism. So this blood comes out through the aorta into the arteries, further branching off into smaller arterioles, and then eventually ending up at capillaries. So an aorta, artery, arteriole, and capillaries. At this point, the blood is going to slow down. And when it slows down, it's able to allow nutrients and cells to diffuse through its walls. So blood cells are leaving, oxygen's leaving. It's also picking up waste products so that those things can be brought to the appropriate organ for either removal or metabolism. Once the blood leaves the capillaries and it's done its job here, it will go to venules and then to veins. The venules are a smaller vein that are good at collecting blood and holding that blood. And then veins are a further convergence of all the venules so that it can be brought to the vena cava. The vena cava has, well, there's actually two vena cavas. Um, Below this point or down, um, bringing the blood up is the inferior vena cava. So this vessel will bring blood from the legs, the abdomen, and the pelvic region and bring that blood up into the right atrium from the bottom. And then from the top, we have the superior vena cava. So this is collecting blood from head, neck, and arms. And they both enter the right atrium at different points, but both emptying into that one cavity. Now we're in the right atrium, and this blood will be ejected into the right ventricle. There we go. Now we can see the picture. This travels through what's called the tricuspid valve. After the blood has reached the right ventricle, this valve does not allow blood to flow back. This is very important so that the blood in the heart does not clot, which can be very dangerous, or create increased pressure or a higher workload in the heart, which can lead to cardiomegaly, myocardial infarction, heart failure, and many other things. So then this blood is in the right ventricle and it's still oxygen poor because the body's just used all this blood. So it needs to go to the lungs to get oxygenated. And it goes through the pulmonary artery. There's a right and a left branch to go to the right and left lung. In the lungs, there's also capillary beds that sit on the alveoli. And at this time, oxygen is entering the bloodstream through the alveoli and carbon dioxide is leaving so that we can maintain um, body pH and be ready for further oxygenation. Once the blood has done its job in the lungs, it comes back through the right and left pulmonary vein into the left atrium. The blood's oxygenated and it's ready to go to the rest of the body. So it goes down into the left ventricle after the left atrium's contracted. This goes through our bicuspid or mitral valve into the left ventricle. Now the valve's closed. The blood can't go back, so it has to go up and out through the aorta, which is exactly where we started. There's also an aortic valve, so that blood in the aorta does not come back into the left ventricle, making it more difficult. And that's essentially how the cardiovascular system brings blood, oxygenates it, and then delivers it to the rest of the body. Um, I just want to look closely and quickly at the electrical activity of the heart. Here we have the SA node sinoatrial, meaning self-rate. So it produces a rate or a signal that's going to cause synchronized contraction of the heart. This signal travels to the AV node, but also across, and then down to the bottom of the ventricles, out and around, into what is called the Purkinje fibers, causing a synchronous contraction of the heart and delivery of blood to the body. Thanks for listening.